Welcome back to the Rate Needed segment. In working with the How Long tab of your spreadsheet, did you see how the growth rate and the time elements seesawed? Similar to what I said about the discounting seesaw, it's really powerful to know the How Long seesaw, that when a rate goes down, the time factor goes up. As I mentioned before, we'll see this when you learn to do these calculations on a calculator. It's always important to know how an equation works before you try it on a calculator. We have one more term to look at in the time value of money equation, the growth rate, which we also called the discount rate. Up until now, we've only been talking about the math of compound interest, which is also known as the time value of money, or TVM. But an investment's growth rate usually reflects the risk of an investment. Safe investments tend to earn a fairly low rate of growth, 1% to 3% per year. Risky investments might earn 10% or even much more. But you could lose your money. Let's put that aside. We're giving you a mathematical tool here, and the tool lets you figure out the rate you need to earn to reach your financial goal. If the investment that earns the rate you figure proves to be too risky for you, you need to change your plans or take the chance. Again, we're working with the same equations in the same two versions we used in the last segment. Nothing's new except that now we're solving for the rate factor. We know the time period. So I'm going to work 3 examples just as before, and then it will be your turn. In row 1, we have the same starting figure that we used in the previous segments. We are investing $10,000, and this time we know that we have 10 years to reach our financial goal of $16,289. How much do I have to earn? We've seen it before, 5%. Now, let's fiddle with the time period. In row 2, let's decrease this time to 7 years. This bumps the interest rate I need up from 5% to 7.2%. It's looking like another seesaw. In row 3, let's increase the 10 years to 15 years. This knocks the interest rate down from 5% to 3.3%. Yep, it's a seesaw. And for the same reason as in the last segment, in order to equal a constant 1.6, representing FV divided by PV, then when the rate goes down, N per has to go up to compensate, and vice versa. It's in the math. Now it's your turn. Go to the Rate Needed tab of the spreadsheet you've been working with and try a few. This concludes the Rate Needed segment of this lesson. When you are done working with the spreadsheet, please continue with the summary segment of the lesson, where I'll pull everything together and tell you a little bit about coming lessons.